Hello everyone. Today we will understand Nikitosh and XOR problem of CodeChef September 2015 long challenge. We highly recommend you to read the problem and try to solve it by yourself before continuing with the video. Let's understand the naive approach, which will give you 40 points only, but will help us understand the steps required for getting the final result. We will be discussing 3 approaches, and each one will be a betterment of the previous one. The first approach, that is the naive approach, will give us 40 points and will give TLE for the rest of the part. The second approach will give TLE for some sub problems, and the third one will give us 100 points. So let's understand the first approach, that is the naive approach. Let's consider we have array 1 2 3 1 2 with index 0 1 2 3 4. Now we will be using prefix XOR. You must be knowing prefix. In the last long challenge also there was a problem in which we used prefix sum for finding the answer. It was WOUT problem. Here we will be using prefix XOR. What is prefix XOR? For the first element we copy the element as it is. For the next element we will XOR the one index element with the previous value. So 1 XOR 2 will give us 3, 3 XOR 3 will give us 0, 0 XOR 1 will give us 1, and 1 XOR 2 will give us 3. Similarly, we will calculate prefix XOR for end, from end. That is, we will copy the end element as it is, then we will XOR this with 1, so we will get 3, then XOR this with 3, we will get 0, then XOR it with 2, we will get 2, and XOR it with 1, we will get 3. Now after finding this prefix XOR, okay, let us understand what this prefix XOR values tells us. Okay, at the index I, the value tells us is that XOR of all the values from original array starting with index 0 and ending at I. That is, this value is obtained by XORing all the values from 0 to 2. This will be obtained by XORing all the values from 0 to 3. Similarly, this array Q, the values tells us is that 0 is obtained by XORing all the elements starting from n-1 to that index. So this XOR will give us 0. This XOR will give us 3. So after finding these two arrays, we have to construct two more arrays. This arrays will store the sub array with maximum XOR. So let's say this value 3. What this value tells us is that the maximum sub array from index 0 to 2 will have XOR of 3. So how we are calculating this? For every index I, say let's say 2, for 2 we will first write a of 2 as the value itself. Here the value is 0, and for before that also, for forming A we will use values of P, that is the prefix XOR from start, and for finding B we will be using prefix XOR from end, that is array Q. Now here for finding this value A of 2, we will first copy the P of 2 value, that is 0, and then we will XOR it with all the values in the prefix XOR, that is P. So we will XOR it first, it will be 0, then we XOR it with 1, so 1, XOR it with 3, we get 3, and the previous answer 0. So the maximum among them is 3, so we write 3. Here it is 1, so it is obtained by XORing 1 with 1, it will give 0, 1 with 3 will give us 2, 1 with 0 will give us 0, 1 with 0 will give us 1, and the 1 itself. So maximum among them is 2, that is obtained by 1 with 3. so 2. But what this values tells us, let us understand by taking an example. Let's suppose we are considering 0 0, that is this element, its array, its value is 1, right? We will be considering the original array. Now 0 0 is having 1 and 0 4 will be having this array, right? 1 2 3 1 2. If we XOR them, what we will get is 2 3 1 2, right? That is XOR of 1 to 4, right? We were having 0 0 and another having 0 4. So if we XOR them, we will get 1 4. This is an XOR property. So every value at index I tells us the maximum XOR subarray from I to j, where I is the index at that moment and j is the value from 0 to I. Similarly for B, we will be calculating by using the same technique, but here we will check all the elements from n minus 1 to j, n minus 1 to I. That is, suppose we want to calculate this, so first we copy the element as it is, so 0 will be here, then we XOR this with 2, so answer is 2. So we XOR this with 3, we will get answer as 3. So maximum among them is 0 3 and 2, maximum among them is 3, so answer is 3. Note, we are using P for calculating A and we are using Q for calculating B. Now the value at this index tells us is that the maximum subarray XOR from 0 to 2 is having value 3, and this 3 tells us is that the maximum XOR subarray from this index to n minus 1 is 3. So we will be using this for calculating the final answer. We want the addition of two subarrays whose sum will be maximum. So if we take this element, say, so it tells us that the sum of maximum XOR of subarrays from 0 to 1 is 3. So for the second subarray we have to consider the next array, next index from the next index. That is, if we consider this, then we have to consider all this and the maximum among them will be chosen. So 3 plus maximum among this will be 3 plus 3 6. Here this plus maximum among this, it will be 3. This plus maximum among this, that is 4. So it will give us the, and the maximum among these values will give us the final answer. The answer is 6. But for while checking this, we are using a O of n square, right? Say for every index we are checking all the elements from I plus 1 to n minus 1, right? To avoid this, we can pre-compute some values. That is, we are changing the values in B. What we are doing is copying the element from the end to, now max is 2. If max is here the value is 3 greater than max, so max will be 3 and we write max here. Now here the max is same equal to 3, so we will write max equal to 3 here. Now here the value is 2 less than max, right? So we will ignore this value and write max here. Again this value is 3, same as the max, so we will write max here. So let's consider this one. For previously we were, if we chosen this one, then 1, and we were choosing any of this with which is having maximum value, which was O of n square. But now we have to select this plus this value, because this value tells us is that the maximum among this is 3. So we get 6 as our answer. This was a basic approach, naive approach. This is the code. We are scanning the array, then we are forming the prefix array and calculating the prefix array by using the previous prefix array value and the current array value. Then we are calculating array A. For that, for every index we are checking the XOR of all the values from 0 to that index. That is, for getting this value we check XOR of 0 and 1, 0 and 3 and the value itself. So this is an n square solution. Again we are forming the Q array, that is the prefix end array, and then again we are calculating the B array similarly, and then this one is just to modify the B array. Here we transform this array to this by using this, that is, if B of I is less than B of I plus 1, we ignore the B of I value and write B of I equal to B of I plus 1. And then we are using a for loop to calculate the max, but this solution will give us only 40 points like this one. So we need to improvise our solution, that is optimize it, and we can optimize it only in this part, that is calculating B array and A array. So for calculating these values we need to understand another concept called try. This is a nice article. Let's understand the concept first. What is a try? It is mostly used in dictionaries. Like we have a set of words and they all start with either T, A or I. So in that, those who start with T, they have second character as either O or E. Those who start with TE have third character as TEA or TED or TEN. So in the end we are getting the final words. Now let's understand how to insert an number into this kind of tree. We are using a binary tree where the right tree is used for 1, storing 1, and left for 0. So here consider this tree. Here we are having two numbers, 111 and 010. So for adding another number, say 011, we will traverse from this point. We'll check if 0 is present. Yes, it is that is the left child is present or not. Yes, it is present, so we will go here. Now 1, so we will check again 1 is there or not. Yes, it is there, so we will go here. Now we are here and we will check again 1 is there. No, it is not there, so we will add a node to this tree. So we have 011 stored into the tree. Now again for 110 we will go here, and then there is no 0 node, so we will add it. This is the way we add nodes to the tree. Now for finding the maximum XOR, let's consider we have these two numbers in the tree. This is 111 and 010, and we want to calculate the maximum XOR of any of this number and the given number. The given number is 100, so we want to find any number whose XOR with this number will give us maximum value. So for getting the maximum value, the second number must be the complement of the first number. So 100, the maximum we can have is if the other number is 011, right? So we will get 111. So we will use this property here. We have 100, so we will check if there is a number starting from 0. so that our XOR will have the first element as 1. So we will check 0. Yes, there is one 0, so we will go there. Now we want second as 1, so we will go right. Yes, there is 1, so we will go right. So we have 0 1, and then we want again 1, but there is no 1 here, so we have to consider this node only, that is we will have 0 1 0. We have to compromise our answer. So the maximum number which we can have whose XOR with this value will be maximum is 0 1 0. This logic will be used in our problem. This is the solution. Now before that, this solution also is not the best solution, as it will give TLE for 3 cases. Let's understand the operations here. We are creating a tree, and there are 2 utility functions. One is insert and the other is search. Let's understand the 2 functions first. Say we have a tree and we want to insert a number x, so we'll be converting those numbers into 32-bit number or 32-bit binary number. So say we have x equal to 5, so it will be 0 0 0 0, and the last 3 numbers bits will be 1 0 1. So for the 31st bit, we will check if the bit is 1 or 0 in x. In x, since x is 5, it is 0, right, the 31st bit. So how we are checking? We are using this binary bitwise operation. Here this 1 shift I, this will give us a binary number which is equivalent to this 1 set at 31st bit, and rest all bits will be 0. And if we AND it with x, if the 31st bit of x is set to 1, then it will give us 1, else it will give us 0. So it is used to check the ith bit is set or not. So here it is not set, so we will come here in the else part. In the else part, we will check if that node is present or not. If it is present, then we will go to that node. So that is while inserting 0 0 1 1, we first check, we are checking if 0 is present. Yes, it is present, so we are just jumping to that node. This is same as this code. If it is present, then we are jumping to that node equal to node 0, and then else if it is not present, then we are creating a node and inserting it like this case, where we wanted a 1 but it was not there, so we inserted 1. This was if the current bit is 0. If the current bit is 1, then we will go inside this if statement. In this if statement also we will do the same thing, that is check if the the right child is set or not. If it is set, then we will just jump to that node, else we will create a node and go to that node. This was for inserting. Let's understand for searching. For searching, we are using the same method as for inserting, just we are reversing. So say we want to calculate a number in the node which will be having the maximum XOR with this number. So for that, if the ith bit of x is set to 1, then we want to go to 0th bit, right? Here this is x, okay, so the second bit is set to 1, so we will go to 0th bit. that is we will choose the 0 path because it will give us maximum. So we are doing the same thing here. If it is 1, then we are going to the 0 node, 0 branch, and if it is null, not null, then we are jumping to that node, else we are forced to take the 1 node. It will decrease our value, but we have to do it. And we are, whenever we are taking a right node, so we are forming this y value, that is our final number whose maximum XOR, whose XOR with the given number will be maximum. This is the else part. Same approach. We are, if it is 0, the ith bit of x is 0, then we are going in the right direction, that is we are selecting a number whose bit is 1, and for 1 we are doing the same thing, forming the number. We are first forming the prefix array. We are using a single loop for forming the prefix array and the array A and B. For here we will be using one for loop for calculating prefix and A array. So for prefix we will be performing this operation, and then for calculating the A array we will search, we will use the search operation, and it will give us the number whose XOR with this number will give us maximum. So we are inserting, so this is the max is our A array A, so A array, and then inserting that prefix number into the node, into the tree. We are inserting the prefix number into the tree. Similarly for the Q array, we are calculating the Q array. We are using the same array for calculating Q, and then max 2 is our B array, and after forming this two arrays, this is for optimizing our B array as done previously, and in the end we are calculating the solution as done previously. This solution is also not that optimized, as it won't give us 100 points, so we need to optimize it. So to avoid this, avoid the use of structured tree, we can have a 2D array. We are forming the, consider the solution by taking an example. First we are initializing a global variable to 0, and for every turn of operation, that is every inserting of bit, we will be incrementing this value. Now say we want to insert this binary number, first we will be inserting 1, so we would first increment this, so it would be 1, and for whenever we are inserting a new number, we would initialize a node to 0. So t of node of comma 1 will be equal to the idx is 1 here, so we have t of 0 1 equal to 1. Now we will be inserting this number, this bit. For this again we would be, and after this step we will again make node equal to idx. Node was first 0, now node will be 1. Now t of node comma 1 will be equal to idx, the new idx. Idx is incremented every time a new bit is to be inserted, so now it would be 2. Idx is 2. Now we would again make node equal to idx equal to 2, and idx plus plus, so idx is 3. Now again it is 1, so t of this 1 tells us that we want to insert at column 1, and this value gives us the next row. So next row, t of 2 comma 1 equal to 3. So we have inserted the first element. Now idx is 3 and node is also equal to 3. Now for inserting the new element 0 and 0, again since it is the start of insertion, we would again initialize node to 0. So node equal, at this moment node equal to 0, idx equal to 3, idx equal to 4, since it is incremented for every bit operation, so it would be 4, and since it is 0, so column will be 0, so t of 0 0 will give us 4. Now this 4 comes here, that is row, that is we copy row as the previous idx, so idx is 4 previously, and increment the idx, so current idx is 5, and since it is 1, so column is 1, so t of 4 comma 1 equal to 5. Similarly t of 5 comma 0 equal to 6. Now again we want to insert 1 0 0, again the idx is 6, right, and node will be 0, and now idx is incremented by 1, so it will be 7. Now again we want to insert this number, that is 1 0 0. For 1 it would be, for this beginning it would be node 0, and column will be, since it is 1, so column will be 1, and it is, since it is already formed, right, it is 1, so we'll directly copy it, so t of 0 1 equal to 1. Now we would copy this idx value here, that is row number, and column will be equal to the character, so it is 0, so t of 1 0 would be equal to idx plus plus, so it was 6 here, so it would be 7 here. Then again t of 7 0, it would be 8, right. Now let us say we want to calculate maximum XOR with 0 1 1, right. We have these 3 numbers inserted, and the maximum would be this number, right. 0 1 1 XOR 1 0 0 would give us 1 1 1. So 0 1 1, for 0 1 1 we will check if there is a number 1 0 0 for maximum XOR. If it is not there, we will check for 1 0 1. Likewise, so first we want to check if 1 0 0 is present, so we would check, for checking 1 0 0, the column will be 1, right, and row will be, node will be 0 again for the start, so t of 0 1 is 1. Now it is 0 next, so t of 1, row number would be 1 and column will be 0, equal to, it is 7 given, right, and then t of 7 0 would give us 8, right, and at this 8 position we have 1 0 0, so our answer is 1 0 0, and we obtain this by using this array, this another variable y. First it is initialized to 0, and whenever we have a 1, here we have 1, right, so we got this is at the third, that is maximum bit position, so we write 1 here, then it is 0, so 0, then it is 0 again, so 0. This is the solution. First we are initializing, first we are declaring this two global variable. First is the 2D array of row number, rows equal to max and column equal to 2, and we have this global variable idx, it is initially 0. Now we are initializing the array, that is we are writing -1 to every row and column number, so, and also initializing idx to 0. Now for inserting we get the number x, So similarly as the previous solutions, we would insert every bit, that is 32 bits, and here we are checking if it is 1. If it is 1, checking if the bit is 1. If it is 1, we are checking if the node is set or not, that is that node column 1 is, if it is -1, it tells us that it is not yet set, so we have to set it. So we increment idx, then we write in tree of node comma 1 equal to idx, and then write make node equal to idx. Here this node is equal to the previous idx, right? Else if it is present, then we just copy the node, copy the value into the node. Else, like this is similar to this case where the value is previously set, so we just copy it because we need to use it in the next row, right? Similarly, if it is 0, then we check if it is set or not. If it is not set, then we increment idx and write it to the tree node 0, as node is the previous idx, and 0 because it is 0, and then make node equal to idx. Else we copy the value into the node for further operations. This was the insert operation. Now consider search operation. Here we would check, we would do the similar operations, like we would check for every bit. If it is 1, then we check if it is set or not. If it is set, then we copy the node, copy the value into the node. Else we copy the 1 value, that is we want 0 but we don't have 0, we have 1, so we need to compromise with our solution and copy that node value into the node. And whenever we are using a 1, so we have to update this y value. When the ith bit of x is 0, then for that we want 1, right? So similar approach, and we are doing the same operations that we had done in the previous solution, that is this solution, that is first forming the prefix value, then searching that into the tree, and then finding the maximum XOR, and then also inserting the prefix value. Similarly for the sum 2, that is from backward, and then optimizing our b value and then printing the final answer.